Good morning, students. Students, this lesson is of class 9th for the subject of physics. Topic: refraction of light, which is covered in chapter 4, refraction of light at plane surfaces. And this topic is on page number 70 of your textbook titled Concise Physics by Selena Publications, and is being submitted to you on 19th October 2020. Students, we have already learned that if a ray travels from denser to rarer medium, its speed increases and the light ray bends away from the normal. And if a ray travels from rarer to denser medium, its speed decreases and the light rays bends towards the normal. Students, see the diagram shown to you. This we have already discussed in the notes provided to you on 12th October 2020. Suppose this is an incident ray shown to you. So, if this is an incident ray, that means this is the arrow and dotted line is normal. So the angle between incident ray and normal is known as angle of incidence. So students, this is an incident ray falling on a glass slab, and the angle made between incident ray and the normal is known as angle of incidence. If we were not having this glass slab, then what would happen? This incident ray would have traveled like this. There would have been no change in the path of incident ray. It would have traveled in same direction. But students, here you are having a different medium. The light has to travel from air to glass. So that means from rarer to denser medium. Thus, the light will bend towards the normal. Now, the light is not going in the same direction. The speed of light has decreased and it will go towards the normal. And this angle between the normal and refracted ray. This ray is known as refracted ray. The ray shown to you in red color means refracted ray, and angle between normal and refracted ray is angle of refraction. Now students, when this refracted ray reaches the other part of glass slab, again this red colored light has to travel from glass to air, that is from denser to rarer medium, and thus the light will move away from the normal. Now students, see, this refracted ray would have gone like this, but since there is change in medium, the light has to travel from denser to rarer medium. Its speed will increase, due to which the light ray will bend away from the normal. So now students, this is your emergent ray. This green colored ray, which is finally coming out of your glass slab, is known as emergent ray. And students, these two rays shown outside the glass slab should be coming parallel to each other. The angle between emergent ray and normal after refraction, so this angle is angle of emergence. Angle of emergence. And students, emergent ray will be parallel to the original direction of incident ray. The both rays will be parallel to each other. And the displacement between the two rays will be known as lateral displacement. So the perpendicular distance between emergent and original direction of incident ray was known as lateral displacement. This whole concept was already discussed last week, and today, students, we will discuss the case of normal incidence. So, students, in case of normal incidence, that is when light travels from one medium is incident normally on the other medium, then the path of light does not change, but its speed changes as it goes from one medium to another medium. So students, you can observe figure 1 given on page number 1 of the notes provided to you on 19th October 2020. So here you can see a light which is falling in the direction of normal, and this incident ray is parallel to the normal such that angle of incidence is not 90° here. Why? Because angle of incidence is angle between normal and incident ray. Since both are parallel to each other, therefore angle of incidence is 0° and angle of refraction in this case will also be 0°. It means that after refraction, the light will move in same direction without getting deviated. That is, its path will not change. But yes, we know that speed of light decreases when it enters glass slab, since it is a denser medium as compared to the rarer medium, which is air. So further now we are ready to discuss about cause of refraction. Students, when a ray of light passes from one medium to another medium, its direction changes because of the change in speed of light in going from one medium to another medium. So the cause of refraction is the change in speed of light when it goes from one medium to another medium. So students, heading towards laws of refraction, as we have done laws of reflection in class 9th, similarly we are having two laws of refraction. First law states that the incident ray, refracted ray, and the normal at the point of incidence lies in same plane. That is, incident ray, refracted ray, and the normal lies in the same plane at the point of incidence. Now students, coming to second point, which is very important, the ratio of sine of the angle of incidence to the sine of the angle of refraction is constant for the pair of given media. So students, as you must have done sine theta, cosine theta in your mathematics by now, so now you are comfortable with this term sine. So it is the sine of angle of incidence divided by sine of angle of refraction, and their ratio is constant, which is given by 1 mu 2. It is written as 1 mu 2, and this is called as refractive index of the second medium with respect to first medium. So that means mu 2 divided by mu 1. Basically, we are comparing mu 2 with mu 1. So that means refractive index of second medium as compared to refractive index of first medium. Students, this law is also having a name. It is named as Snell's law. SNELL''S. Snell's law. It is SNELL'S. Snell's law. Snell's law states that sine of angle of incidence divided by sine of angle of refraction is equal to refractive index 1 mu 2 can be written as mu 2 divided by mu 1. So this is the statement of Snell's law. Now, moving further, we can define refractive index as refractive index of second medium with respect to the first medium is defined as the ratio of sine of angle of incidence in first medium to the sine of angle of refraction in the second medium. Students, this underlined part is very important. You can see I have underlined it in your notes also. So, sine of angle of incidence in first medium to the sine of angle of refraction in second medium. So students, angle of incidence was already in first medium. If it was air, we were drawing angle of incidence in air, and angle of refraction was in second medium when we were drawing it in glass. Glass was considered as second medium. So students, now let us see figure number 2. In this figure, we are having a glass slab and the light is incident from air on the glass slab such that after refraction, the light has bent towards the normal. Angle of incidence is given to be 45 degree and it is in first medium air. And angle of refraction is 30 degree and it is in second medium, that is glass slab. So now if you want to find refractive index of glass, then we will take ratio of refractive index of glass with respect to air. So compare refractive index of glass with refractive index of air, that is mu of glass divided by mu of air, which will be equal to sine of angle of incidence divided by sine of angle of refraction. Angle of incidence can be written as 45 degree and sine of refraction can be written as sine 30 degree. So we will be having sine 45 degree divided by sine 30 degree. Now students, as done in mathematics, the value of sine 45 degree is 1 divided by square root of 2. That is 1 divided by under root 2. And sine 30 is half. So on solving this, after putting the values, so listen, see here it will come 2 upon root 2. How? It can be seen from here that we were having 1 upon root 2 divided by half. So how to write it? It can be written as 1 divided by root 2 multiply by 2 divided by 1. So further it becomes 2 upon square root of 2 and this 2 in the numerator, how to write down? It can be written as root 2 multiply by root 2 whole divided by square root of 2. Finally, this root 2 cancels with each other and you are having mu of glass, which we have to find, divided by mu of air is equal to square root of 2. Now, refractive index of air is 1. So, if you take 1 on this side, your refractive index of glass will come to be equal to root 2, and students, the value of root 2 is 1.414. So you can write down this as your refractive index of glass, that is 1.414. 1.414. Now students, remember that frequency of light depends on the source of light. So it does not depend on the medium in which light is traveling, and hence it does not change on refraction. What I want to say is, if you are having sun as a source of light, the sun will be emitting light in all directions and the light of sun travels in space, it reaches Earth, and in Earth it can go to water, it can go to any glass medium or any other transparent medium. It travels in air. So despite of the rays of sun traveling in different mediums, the frequency of the light will depend on the source, which is here our sun. So if light travels in different medium, then also the frequency of light does not changes, because it depends only on the source. As we have already studied in class 9th earlier, that velocity is equal to product of frequency and wavelength. That is, V is equal to nu multiply by lambda. So from here, we can have lambda is equal to V divided by frequency. Now students, when light passes from a rarer medium, then wavelength decreases. When light passes from rarer to denser medium, the wavelength decreases. Because speed is increasing when the light goes from denser to rarer. But now the case is rarer to denser. So when the light goes from rarer to denser, the speed of light decreases. If light is decreases, speed is decreasing, so wavelength will also decrease, since it is directly proportional to each other and frequency remains unchanged. So if velocity increases, wavelength also increases, and if velocity of the light decreases, then wavelength also decreases. So again I repeat here. Now when light passes from a rarer to denser medium, wavelength decreases. Since velocity of light decreases as wavelength and speed of light are directly proportional to each other, keeping the frequency unchanged. Similarly, when light passes from a denser to rarer medium, light passes from denser to rarer medium. Its wavelength increases. Since speed of light increases, and again its frequency remains unchanged. Now students, further we will study a very important concept, that is conditions for light ray to pass undeviated on refraction. So here we have to discuss when the light is not changing its path on refraction. First case can be this light is incident normally. That is, when angle of incidence is 0 degree, such that angle of refraction is also 0 degree. Secondly, when the refractive index of the medium 2 is same as that of medium 1. If both mediums are equal, there will be no rarer and denser medium. Thus, the light will not change its path. So students, see here. If you are having same medium on both sides, suppose here you are having air whose refractive index is equal to 1, and the other medium is also air whose refractive index is 1. So if this ray is taken as normal, if this is your normal and the light is incident, suppose at an angle of 45 degree. This is the direction of incident ray, which is at an angle 45 degree. So this is your angle of incidence, which is 45 degree. Now the ray either bends towards the normal if you are having denser medium, or it goes away from the normal if you are having rarer medium. But since both mediums are equal, that means the ray of the light will neither bend towards or away from the medium. The ray will continue to move in same path. That means it will not change its path. So this can be a condition when the ray does not changes its path, and the other condition can be that angle of incidence is 0 degree, which we have already discussed on page number 1 of the notes sent to you earlier. We have discussed this here on page number 1, figure number 1. We will discuss now the relationship between wavelength in the two medium. So students, wavelength of light in any other medium like glass, water, oil, diamond, any medium, refractive index changes. So therefore, wavelength of light in any other medium is equal to wavelength of the incident light in air divided by the refractive index of the medium. You have to learn this formula as we have certain numerical based on this. So wavelength of light in any other medium is equal to wavelength of light in air divided by refractive index of the medium. So students, note that when light passes from rarer to denser medium, refractive index will be greater than 1. Why? Because the light is going from rarer to denser medium. So wavelength will decrease. When light passes from denser to rarer medium, the refractive index is less than 1. So its wavelength increases. In short, we can learn that when light goes from rarer to denser medium, when the light goes from rarer to denser medium, the wavelength of light in that medium decreases. The wavelength of light in that medium decreases as velocity also decreases. Velocity will also decrease when the light goes from rarer to denser. And we have studied today that wavelength is directly proportional to velocity of light. So if velocity of light in medium decreases, the wavelength of light in that medium will also decrease. And point 2 was when light passes from a denser to rarer medium, the refractive index decreases, its speed increases, and thus the wavelength of light also increases.